Hello, I'm Jennifer, and this is my Lab 3 Black Hole and Orbits. This video will include an introduction, Part 1, Part 2, results, discussion, and a conclusion. The purpose of Part 1 was to estimate the mass of the black hole using a computational model. The purpose of Part 2 was to find the initial velocity for a spaceship to orbit the Moon and the planet without crashing. The fundamental physics principles used were Newton's second law, parallel and perpendicular forces, universal law of gravity. The mass of the black hole was estimated to be 1.5 e to 34, and the initial velocity was 668.331 meters per second. Some of the equations used in this lab were velocity and position update formulas, Newton's second law, gravitational force, and parallel forces, which are parallel to the direction of motion, and perpendicular forces, which are perpendicular to the parallel component. The system in Part 1 is a black hole, the surroundings is a star, the system in Part 2 is a spaceship and moon, the surroundings is a planet. And some assumptions I made were that the only forces in both parts are gravity from the surrounding masses. The initial conditions in Part 1 include gravitational constant, the star's mass, and the time of day in seconds. So this is my code for Part 1. And the first thing you can see here is the initial and final momentum, which we found by multiplying the mass of star and the final and initial velocity. Then we found the change of velocity and momentum by multiplying v final by v initial, and same with p final, p initial. We also found delta t, well, dp dt, that we're then going to plug into F net because that is the equation, and by saying delta p divided by delta t. And then we found p hat, which is pretty easy. Then we plugged all of that in to find the parallel components. And we also did the same thing pretty much to find the perpendicular component. At the very end, we calculated the mass of the black hole using that equation at the bottom, and which is basically just the gravitational equation switched around to find the mass. From Part 1, we found the mass of the black hole was calculated by the computational model, and from here I found the average of all the masses in an Excel sheet. The average mass was 1.58 e 34 kilograms. Here on the right you can see the computational model put out, and you can see the planet going around the black hole, and from here we calculated each position and velocity, and then we finally got the mass of the black hole from using the gravitational equation. How are net force and its parallel and perpendicular components different from the rate of change of momentum and its parallel and perpendicular components? Well, the net force and change of momentum point in the same direction, while the net force is equal to the rate of change of momentum with respect to time. The parallel components for net force correlate to the change in speed, and perpendicular components to a change in direction. The initial conditions for Part 2 include the gravitational constant, again, the mass of the planet, mass of the moon, and mass of the ship, and also includes the change in time. For Part 2's code, I included the position and velocity update, and also the gravity equations to find the net force of each object, which I had to also calculate the distance between each corresponding objects. This is my results for Part 2. And as you can see, the orbit isn't fully complete because my code took too long to generate. However, you can still see the moon's orbital speed, which is 668.321 meters per second. And some differences found between Part 1 and Part 2 is that Part 1 used a gravity equation to find the mass of the black hole, while Part 2 uses equations to find the net force of each object and find the velocity. What would need to be included in the computational model to predict the motion of the entire system when the system has a black hole, a star, a planet, and a moon? You would need to include every gravitational interaction between every object and apply Newton's second law to update position and velocity. Some sources of error in Lab 2 would include the mass of the black hole from Part 1, and wrong formulas may have been plugged in, causing a wrong. To conclude this video, Newton's second law and gravitational were used to find the mass of the black hole and the initial velocity of the spaceship. Thank you for watching!